Hey, welcome to iLecture Online, and here's our first example, a general example of how to deal with projectile motion. It's kind of a classic example. We have a plane that's flying along, bringing supplies to a Boy Scout that's running out of food in the wilderness. And let's say the plane is a height of 2,000 meters. The plane is flying at 50 meters per second. It's level. And at what point, how far away from the Boy Scout should the bag be dropped so that the bag will land right next to the Boy Scout? Okay, and also since, of course, a navigator typically will find that position, location through an angle relative to the horizontal, we also need to find that angle. Since there is no initial velocities in an angle away from either the horizontal or vertical, we don't have to find the components, so we can go right into the approach saying time in the air is equal to question mark. Let's find the time in the air, and of course the equation for that is y equals y sub naught plus v sub naught in the y direction times time plus 1/2 gt squared. Realizing here that in this case there is no initial velocity in the y direction because it simply dropped from something flying at a level, so this goes to 0. The final height will be 0, so we can say 0 is equal to 2,000 minus 4.9 t squared. Moving that over here, we can get that as 4.9 t squared equals 2,000. Divide both sides by 4.9. And taking the square root, we can say that t is equal to the square root of 2,000 divided by 4.9. Of course, these cancel out. And let's see what that is equal to. 2,000 divided by 4.9. Take the square root. And we have the time equals to 20.2 seconds. So we have time in the air. Next thing we need to do is see how far that object will fly in that amount of time. So that we can find by using the equation x equals v initial in the x direction times time. In this case, the initial velocity of the package is the same as the initial velocity of the plane. So it will be 50 meters per second multiplied times 20.2 seconds. And so that would be equal to 1,010 meters. So if the plane drops the food 1,010 meters, maybe you should drop it about 1,000 meters before it gets to the Boy Scout, and the package will land 10 meters behind the Boy Scout, a little safer that way. And then if we want to find that angle, notice that this will be a triangle. This will be the opposite side to the triangle, which is 2,000 meters in height. The horizontal will be 1,010 meters, so we use the arctangent for that. So theta equals the arctangent of the opposite side over the adjacent side. And so in this case, that will be the arctangent of the opposite side, which is 2,000 divided by adjacent side of 1,010. And so let's see what that's equal to. Take the arctangent of that, and that will be 63 degrees. So when the navigator is looking through the scope, finds the Boy Scout at an angle of 63 degrees below the horizontal, push a button, drop the bag, and the bag will land really close to the Boy Scout. And that's how you do that problem.